count up how many protons are in atom 1. Now, protons are distinguished by the positive, and electrons would be the negative, neutrons would be the white ones that are neutral. Okay? How many protons does atom 1 have? 5. How many neutrons does it have? 5. I see 1, 2, 3, 4, 5, 6. So what's the mass number going to be? Ooh, how do we get the mass? Yeah, how'd you get that, Jonah? Yeah, guys, to get the mass number, you just add up your protons and neutrons. Piece of cake. Now, atom 2. How many protons does atom 2 have? 9. All right. How many neutrons does it have? What's the mass number? 16. Now, what element, guys, would atom 1 be? How can we figure that out? Periodic table. Oh. What is it? Nope. What? Nope. So I've heard sodium and I've heard carbon, but they're both wrong. Andrew? How do you know it's boron?
Because it has 5 protons.
Protons, guys. The number of protons tells you what element it is. But I like where your heads are at, even though you said sodium or neutron or carbon. Okay? I get it. I know where it comes from. First time we're seeing it. You look at the number of protons, tells you, matches up. So what element is atom number 2? Fluorine. Now, let me ask you this. Does the mass number that we have for atom 1 match up with what's on your reference table? What's the mass number you have on your reference table, guys, for boron? 10.81. That has a decimal. How come we don't have a decimal here, do you think? Because what? It's a basic picture. Okay. I can understand that. Why else don't we have a decimal with ours? Let me ask you this. Can you have part of... Well, first off, what makes up the mass of an atom? What element? What subatomic particles? Protons and neutrons. Guys, can we have like a fraction of either of those? No, we can't. Okay? They're whole numbers just like what we see here within in an individual atom. So we're going to talk about why you have a decimal on your periodic table a little bit later on. Okay? But think about it. You can't, when you have just one atom, you're not going to have a decimal because you have part of a proton or part of a neutron. What's the mass number of fluorine on your periodic table? Rounded to the nearest whole number. 19. We have what here, though, for our mass number? 16. That's a little off, right? When you look on your periodic table, fluorine has a mass of 19. But this one is different, okay? And that happens all the time. This is what's called an isotope, okay? Isotopes, this is just a picture. Again, you don't have this in your notes right now. But guys, what I have right here is, this is just a piece of magnesium ribbon. And then the big circle is kind of like a magnified view of what's going on. Are all those magnesiums the same that are in there? No. We've got magnesium 26 here. Magnesium 24. I see a magnesium 25. Now, when you take a look at this picture, what's the most common mass number that we have here? 24. What's the mass number that you have, or the average atomic mass that you have on your periodic table? Is it? 24.3, right? So what this is showing, guys, and we're going to talk about average atomic mass maybe today, otherwise tomorrow and Thursday. It's an average, a weighted average of all the naturally occurring isotopes. And we can see here that most of these in this circle are 24. Well, when we look at the average, it's closer to 24 than it is to 25 or 26 because you have a lot more of those occurring. Isotopes are naturally occurring. All right? This is now in your notes. Guys, they are atoms of the same element, but they have a different mass number. Same atomic number, which again, what does atomic number tell us? What corresponds with atomic number? The number of what? Protons. So protons doesn't change. but the mass is changing. So what do they have a different number of? Different number of neutrons. Okay, different number of neutrons. They're still the same element because they have that identity piece. They still have the same blood or blood type. Okay, still the same fingerprints. That's the protons. Okay, but they have a different mass number because they have a different number of neutrons. Why does this happen? To be honest, guys, I don't know. It happens, though. It's naturally occurring. Some are more stable. When we talk about radioactivity, that can play a part in it, why there's so many different isotopes. But it's just something that's naturally occurring. Do neutrons have a charge? No, so they're not affecting necessarily the chemistry of it or the balance of charge. It's just there to help it. So we got 3 isotopes for carbon. Maybe you've heard about carbon-14 before, like carbon-14 dating. We'll talk more about that later this year. But we got to figure out the numbers of protons, neutrons, and electrons. This is what you guys are going to do on your quiz on Friday of this week, is count atoms. All right? So, of those 3 subatomic particles, which one should we always start with? What do you think? Nope, not necessarily the smallest one. It might be the smallest one. What'd you say? Okay, we're gonna. Is that what you meant, Mitch? Like C12? Yeah. Okay. Yeah, we're starting. I'm sorry. We are doing C12 first. I mean, within that, which one of those subatomic particles are we going to figure out first? Protons, right? Why? What's that? It never changes. How do we figure out the number of protons, guys? It's the what? Atomic number. So it's always going to be given to us. If it's not here in the lower left corner, let's say this was gone, we still have the element symbol that we can look up on our periodic table. So always start with your protons first, and everything else is like dominoes. It'll fall into place. How many protons do we have with carbon-12? Is that going to change for any of these carbons? No, so let's just fill it in. We have 6 protons for every atom of carbon. Doesn't matter what else is going on. Now, what might be the next easiest, especially with this one, to figure out? Why do you say electrons, Nick? I would agree with you wholeheartedly. Did you just take a guess and say electrons? Yeah, okay, that's fine. He's right. Why would electrons, guys, in this case, be the next easiest to figure out? So mass, when we figure out neutrons, we're going to have to deal with the mass, right? So that's going to be an extra step we have to do. Sam, you had your hand up. It's the same number as protons. Why? Does this have a charge on it? Is there a charge up here? No. Guys, when it's neutral, that means the protons and electrons are going to be the same. Do either of our other 2 isotopes have a charge on them? No, they don't. So that means their electrons are going to be the same as well, because they're equal. Okay? Now, we got to come to neutrons. They will probably be the ones you save until the end. Okay? So like Eden was saying, there's something else we have to do. How do we figure out the number of neutrons? If you look back in your notes, guys, the number of neutrons, if we were to write out an equation for it, it would look something like this. Neutrons is going to be the mass number minus our protons, which we already have in our notes. But like Nick said, the way it's written out right here in this symbol notation, he's saying take the 12 minus the 6, and that's going to leave us with 6 in that one. But how many will we have for carbon-13? 7. And how about for carbon-14? So notice, guys, they're the same element. But what's changing is the number of neutrons. Okay? So when you figure out the neutrons, I typically will save those until the end. I'll do protons first every time. Then I'll do my electrons. Then I will save neutrons until the end. Now, this was simple mental math. It may not always be that case, depending on the size of the atom you have. I want you guys to go ahead and do the second example that's in your notes. Now, notice, this is written out a little bit differently, right? Guys, this is the hyphen notation that we talked about before. What do you think that number tells you right there? Okay, so number of protons. Let's take a look at our periodic table. Does that correspond to the number of protons here with uranium? How many protons does uranium have? 92. So that number can't tell us the number of protons, which means, can it be the number of electrons either? No. So what is that number telling you? The mass, guys. Hyphen notation, when it's written out like this, okay, it tells you the mass number. Think about it. If you were to match it up, guys, to any of the numbers that are in your box on your periodic table for uranium, it's closest to the average atomic mass. Now, again, we said that mass number is rounded. It's going to be a whole number because you can't have part of protons or part of neutrons. Okay? So now I want you guys to go through and figure out the number of neutrons and electrons for each of these. All right, do electrons. How many electrons does uranium-238 have? 92. How about uranium-240? Okay, that's pretty easy. Now, neutrons, guys, you've got to take your mass number minus your number of protons. So it's going to be 238 minus 92. How many neutrons do we have there? How many will we have with the other one? Okay. Piece of cake? Super easy. Good. So let's go through and practice this now on a greater scale. Okay, we're going to do a couple key examples together, and then you guys are going to have a chance to practice. Actually, we're going to do one more piece of notes, and then I'll have to give you guys a chance to practice. So, if you're given a chart like this, like your quiz on Friday, guys, I'm going to give you a chart similar to this one right here. Okay? You just got to fill in the missing pieces. Atomic number, super easy. What's the atomic number for hydrogen? 1. Now, atomic mass, where do we get the atomic mass from? Top left on your periodic table. Are there decimals with the atomic mass? Yes. So what's the atomic mass of hydrogen? Okay, you're going to copy that whole number down, guys. So far, when we have a chart like this, we filled in both of these numbers directly from our periodic table. We're just copying. Now, the mass number, though, we said was different. Here's the thing, guys. If they don't give you a mass number in the symbol, like in the upper left corner, you're going to round the atomic mass. But if they give you hyphen notation or they give you a whole number in the upper left corner of your symbol, then you put that down. So what's our mass number going to be here? 1. We're just going to round it. How many protons does hydrogen have? 1, because it's the same as the atomic number. How many electrons will this one have? Why? Because is there a charge? No. Neutrons we have 0. That is the only element. That is the only element, guys, in the periodic table that has no neutrons. Hydrogen is very unique because of that. All right, let's take a look at the second line. Ooh, what's different now about this that we haven't seen before? It's got a charge, so we got to do something else with that. Is the atomic number going to change? Is the atomic mass going to change? Is my mass number going to change? Nope, because they didn't give us anything in the upper left corner, so we're going to round the atomic mass. Is my number of protons going to change? Is my number of neutrons going to change? Is my number of electrons going to change? Now, let's think about it. We haven't done an example like this yet, but I want you guys to kind of think about it. If I have a positive charge, how do I figure out the number of electrons? Which do I have more of, first off, if it's an overall positive charge? Do I have more positive protons or more negative electrons? Positive protons. So my number of protons should be higher. So what are we going to do to figure out the number of electrons? The quick trick, guys, do the opposite of whatever the sign is. So if you see a +1, you're going to subtract 1 from the number of protons. If you see a negative, you're going to add that number to the number of protons. So how many electrons will we have here? 0. And that should make sense because we have an overall positive charge. If I look here in my chart, oh, here's +1, there's 0, so my overall charge is +1. Here I've got a +1 and a -1, therefore it's an overall charge of 0. Does that make sense? I want you guys to try on your own the next 3 rows. The next 3 rows. Quick. Carbon. What's the atomic number for carbon? 6. What's my atomic mass for carbon? What would be the mass number? Now, where do I need to look for this mass number? Oh, look, they gave it to me in my top left. So that means my mass number is going to be 12. How many protons? Neutrons. And what about electrons? Is there a charge right here? No, so therefore my electrons are going to be the same as my which is 6. Now, the next one, lithium. What's the atomic number of lithium? Atomic mass? My mass number. Now, how did you get 7? Because they give it to you, right? You did not round it because they gave it to you. Just happened to be the same this time. How many protons does lithium have? Neutrons? And what about electrons? Oh, so I hear a bunch of ones. Why do you say 2, Caleb? You seem adamant. Right. Whatever the sign is, guys, do the opposite to the number of protons. So I have 3 protons minus 1 for my plus charge because I lost it. Think about it, guys. Cations are positive. Cations lose electrons. Anions gain electrons. So if you think about it like that, when you see a positive, it loses that electron. You're going to take it away. You're going to subtract it. Anions are negative. They gain electrons. They pull it in. You're going to add it to it. Okay? Now, the next one might be a little bit more tricky. What's the atomic number of chlorine? 17. Atomic mass? 35.45. What's the mass number going to be? 35. Why? Because we were given it in our symbol. Protons should be? Neutrons should be? What about our number of electrons? Yeah, good. It's going to be 18 because, again, negative, we're going to add it. We should have more electrons than protons. All right, I want to introduce one new concept, guys, one other new piece, and that is called atomic mass. Okay, why do we have the decimals? Because they're an average of all the different isotopes. Okay, they're an average of all the different isotopes. It's a weighted average. Where else might you guys see a weighted average in your everyday life? Yeah, your grades, right? Tests in here are 40% of your grade. Quizzes are 35%. And then labs are the other 25%. So it's not just, they're all weighted equally. They're different. AP classes carry a higher weight than regular classes. All right, so they can affect your GPA more. So what we're going to do is you're going to be given the percent abundance of an isotope in decimal form. Okay? And you're going to multiply by the mass of that isotope. And you're just going to keep doing that, and then you're going to add them all up at the end. So it's actually pretty simple. So let's go through and do an example together. All right? The exact mass of each isotope is given to you. Chlorine has 2 naturally occurring isotopes, chlorine 35 and chlorine 37. In the atmosphere, they give us the percentages. So there's 2 ways you can do this. You can do all the math, keep them in percentages, and then divide by 100 at the end. Or you can take your percentages, guys, and convert them to decimals right away. And that's what I do. So here we go. What I'm going to do is I have 2 isotopes. I have chlorine 35 and I have chlorine 37. I highly encourage you guys to write it out the same way to be organized because it's going to make something easier later on that we're going to do. Okay? When we get to percent composition later on. Come on. So, chlorine 35, guys, I've got the mass of chlorine 35. Right? It's got our isotopic mass, so 34.9689. I'm going to multiply that by the percentage. Okay, so it said down here that chlorine 35 is 67.49% abundant. I'm going to take my mass for chlorine 35 and multiply by that percentage. Now I'm going to convert it to decimal form right away. Okay, all I did was divide it by 100 to put it into a decimal. Close my parentheses. Then I'm going to add it to my other isotope. So in that case, 36.9659 multiplied by its percentage, its abundance, 32. So 0.3251. I know. Oh, who can do the math right here for me? 34.9689 times 0.6749. Round it to 2 decimal places, that's fine. Plus the other one. Multiply those 2 together. I don't think you did that right. Yeah, that's off.